Now for the condensation theory, we have discussed about the family, the law of mass action. Okay. So in that case, we are consider in around 1863, the two scientists only consider the Kuhlberg and the Welch. He gave the law that is considered the law of mass action. It means what? When the rate of a substance is react, it's directly proportional to its active mass. Means how much amount of the substance you are taking is directly have the rate of the reaction is directly depends on the what is the active mass of the reactive substance you are taking. Okay, means
Yeah.
here you having a one two substances. Okay,
Yes.
so in that case, how much amount you are taking of this substance, how much moles are you are taking? Okay, in per liter of solution. Okay, that is called as the active mass, means mass or the molecular mass of any substance in per liter volume. Okay, like for
Yeah.
example here you having approx one substance you have a chlorine, you have a 50 gram, okay, in 1 liter. Okay, or one side you having 100 gram per liter. So this active mass is more as compared to this one, right? So here means the rate of reaction for this one is more as compared to this one. Okay, means how much amount of the reactant you are taking, their active mass concentration is directly affect the rate of reaction. Okay, for you having the X any substance you are consider which the mass or the molecular mass of that substance per liter of volume we consider as the active mass, and this active mass is directly proportional to the rate of reaction. This active mass can be represented by the square bracket. Okay, and here is in this you are putting the reactant active mass for the amount you have. For example, you will consider the reversible reaction like A plus B, your reactant, and this one is your product. Both are allowed to get interchange with each other. Okay. So this same equation, if we are following for this one, rate of reaction in the if you consider forward reaction. So for the forward reaction, A and B is work as your reactant part. Okay, so means rate of reaction is directly proportional to the active mass of A and B. Okay, means how much amount of the A and B you have on the basis of the rate of reaction is get increased. Okay, so here you can represent it by RF. RF means rate of reaction of forward reaction is directly proportional to active mass of A and active mass of B. For to removing this proportional sign, we can add it one constant. Okay, let's consider the rate constant, which is represented by K. If suppose for example active mass value is 1, so means rate of reaction is now become constant because it's proportional to directly to the rate constant. Same as if we are consider as rate of reaction for the reverse reaction, in which now the reaction is moved like this. C and D allowed to convert into A and B. Okay, so means now C and B become your reactant part and this A and B become your product. Now that according to the upper formula, rate of reaction which is represented by for the reverse one which is in the subscript R is directly proportional to the active mass of C and active mass of D, because now these are work as a reactant part for the reverse reaction. Same as this proportional sign, if you also remove, you are adding the rate constant. If the concentration of active mass of the C and D is equal to 1, so rate of reverse reaction is also equal to the rate constant. Okay?
Yeah.
If we consider both of things, means approximate for the forward, you will getting this equation. Okay, here you can see there is a n and m in the powers values present, means that is considered as a, here you are having like suppose a plus b get converted into c and a reverse. Suppose here the number of moles of that get increased, n mole of a and m mole of b is converted into the o mole of c and the p mole of d. Okay, means number of concentration get increases. So active mass, if it is directly proportional, so number of moles also get directly proportional. Okay, so there that value is shown by, before if you are not adding the number of mole value having the 1 mole, so it is represented by rate of forward reaction is proportional equal to rate constant and active mass of A and B. But if the number mole is increased, that one we need to mention in the formula. According to that, then multiple by that value, is get the power n, and the B will get power n. Okay?
Yeah, okay.
You'll get it, this one part?
Yeah.
Same as this happens with the rate of reverse reaction. Okay? For example, you are having one reaction, the formation of ammonia. Okay, that is reversible reaction. Here you are having 1 mole of nitrogen gas and 3 mole of hydrogen gas. For rate of forward reaction, means the active mass of this nitrogen and hydrogen is work for the determination of rate of reaction. So rate of reaction is proportional to the 1 mole of nitrogen, active mass of 1 mole of nitrogen and 3 mole of hydrogen. You can see this value is shown here. Okay. And removing this proportional, we can add the constant, that is rate constant. So that is represented by R forward reaction, K, this power is 1, so no need to show this one, and here is power is 3, so we can show like this. Okay, and if this reaction is moving in the reverse direction, means ammonia get converted into nitrogen and hydrogen here. So here its power is 2 because there is 2 mole of ammonia. So it is shown by R, there is a reverse reaction, and shows K and ammonia is power 2. Okay, we'll get it this one. Now why we'll discuss about the law of mass action, because the collision theory is completely based on the explanation of law of mass action. Law of mass action statement says the rate of reaction is directly proportional to the active mass of the reactant. So in the collision theories explain the law of mass action by the experiment. For example, the collision theory statement says, independently proposed by the Max Roth in 1916 and the William Lewis in 1980. He said the rate of any chemical reaction is proportional to number of collisions occur between the reactant part. Okay. For example, this theory says if you want to determine the rate of reaction, you can effectively get by the number of collisions occur between the molecule per unit time. Okay. To understand this concept, we can consider as if we have two reactants, one is A and one is B. Okay. Here, one side you having H2 to a chunk of A. Okay, here you have A2 and B2. We are reacting. Okay, so in that case, if there is a proper collision is occur in between both of parts, this is allowed to get react with this one, this is allowed to get react with this one. So in the proper collision, you will get your actual product. Okay.
Yeah.
And if this collision, if is not occur in proper way, okay, so in that case, when they are allowed to get collision occur in the improper way, they will not get attached the separate one. So again means your product is not allowed to form. Okay, whatever reactant you have before the reaction, the same product you will get it. Okay, means the reaction is not run properly. So the collision between the reactant unit should be in proper way. So how the opposite particle get interact to each other and formation of the reliable product. Okay. So in that case, and also how we can consider as a is related to the collision part, the amount of the reactant number of mole if we'll consider. For example, you have only the one mole, A and B. Okay. So as when it is considered as a law of mass action said, how many number of moles get increased as the active mass of the reactant increases, the rate of reaction increases. If you have 2 moles, there is a one possibility of collision occur, A and B. So the product is how? A. If you having 2 mole of A and 1 mole of B, so there is a possibility get increased. This is also react with that, this one also get. Okay, so means 2 collision occur.
Yeah.
If you are having the reactant concentration increase more, here you have 2 mole of A, 2 mole of B. Okay, there is a one possibility can react with this one possibility can react with this one. Same thing happens, one possibility can react with this one is can react with this one. So means now the number of collisions are 4. Okay. Next one, if one more you are increases. Okay, here you are having A concentration increases more. Now B concentration is this much. So here this one also allowed to show this one collision and for this one. Here is this one also react with this one and this one also. Same as this one also can react with this one and this one. So here is the number of collision values become 6. Okay. If one more element of the B you are increasing, so there is a possibility increase more time, because per mole this collision theory is explain the law of mass action term on the basis of this one. If you are increasing the number of mole of the reactant, the number of collision also get increased. All the elements have the option to react with the all of the 3 another one. So here if you count the number of collision values comes 3 multiplied with 3, its value is 9. Okay, so here you can see when you have only 2, there is a one collision. Here it's one molecule increase, collision values become double. Here one collision values become double of that one. Here this value is get one molecule, if you added the multiple of that one is get increased. Okay, so that will consider as a collision. Like you can see here, only one collision can possible. here is 4 collision is possible, here is 6 collision is possible. Okay, so this is the statement we are considered as a collision theory. Collision theory simply said rate of chemical reaction is proportional to the number of collisions. How many number of collisions is done, the rate of reaction is increased that much. And how the collision increases? Collision increases by the active mass of the reactant. Okay, if the active mass of reactant is more, number of collision is more, and number of collision is more, rate of reaction is increases. Okay, so these three statements are correlated to each other, which completely justify the collision theory.